Welcome back to this lecture 6 of STEG's virtual course on macroeconomic development. STEG is a research program run by CEPR on structural transformation and economic growth with a focus on the macroeconomic development of low-income countries. And as part of that, we've organized this course. STEG and this course are funded as part of the UK aid effort by the Foreign Commonwealth and Development Office. We're very thankful for their financial support to this. We're also thankful for Pete Klenow, who we have today here giving a lecture on misallocation, and for Mandy Chan and Kirsty McNeil and Lauren Waring for helping organize this in the CEPR offices. I just remind you of the ground rules. Pete's going to lecture for about an hour and 15 minutes. And he has a co-author, Kian Ruin, who will answer Q&A. So Doug and I will not have to do that for those who are in the webinar portion. For those who are panelists in the front row of students, we ask you to mute, but you can feel free to unmute if you have a question. Mostly clarifying questions during the talk, and then broader questions Pete will have 15 minutes afterwards for. So with that, I should say the other thing is that the slides are available again on the course website. All the materials, including the Q&A and the recording, will also be available. So with that, let me hand things over to Pete.
All right, thanks very much, Joe. Let me share screen. So I know I'm following Richard Rogerson, who spoke last week, and that's quite fitting because paper by Rastuccia and Rogerson very much inspired Chiang-Tai Hsieh and I to start working on this this topic. And I just remember being really wowed that something I thought was kind of a small Harberger triangle could be this big distortion that could be holding back development. So it really opened my eyes to a lot of channels by which policies may be doing much more damage, or market failures may be doing much more damage than I previously imagined. I previously focused more on technology and human capital. And this opened up a whole new area. So the outline, I'm going to do a very simple model. Richard already laid out models in more detail, and then I'm going to talk about examples of misallocation, including things that aren't misallocation, some of which he touched on and some of which he didn't. And then I'm going to try to recap. Maybe this is the most important part. I'm trying to recap patterns that I see in the last 5 to 10 years of the literature, patterns I see that people have documented about misallocation that I think are quite useful going forward. And then briefly talk about some data sets that are publicly available in firms and plants, and then some other ones that have been used but not so easily available. And then all the remaining time I'll spend on talking about some of my favorite papers in the literature and what the essence of what they do and what I think about them. So this is kind of an elastic portion because I'll just cover as many as I get through. Okay, so my first thing to start out with, and I credit students at Stanford for forcing me to do this, said you use the term misallocation, then you give us a model where it features it. What's the definition of it? So to me, that was helpful for just forcing me to say it's not only that capital and labor or people across occupations, that they could be reallocated, but that the government could do something about that. So not only could they be reallocated in a way that would increase output now or in the future in an efficient way, and so it also forced me to clarify who would benefit from this, and realizing that a lot of it is from a representative agent perspective. So I kind of want to think separately that there's distributional questions that are very important, and then this half is like saying, if you wanted to get to some sort of Pareto frontier, you might want to make sure that you allocate resources efficiently to maximize the size of the pie. But this definition is also helpful for clarifying things like I wouldn't call, the fact that there are trade costs that are shipping costs or there are transportation costs, things that are technological that mean that the rate of return to a resource, might be higher in one location than the other. I wouldn't call that misallocation. The planner, a social planner, couldn't possibly improve on that. They can't repeal gravity, so they can't make that any better. So I wouldn't call that misallocation. And for example, if there's some sort of information problem, it's also, if the government faces that same information problem as the private sector does, it's not clear the government can improve on it. So it may be that the market isn't perfect, but it can't be, I can't call it misallocation that the government could improve on if it can't observe anything more than the private sector can. Okay, so I just want to get that definition out there. And then the simple model, which is nested by a lot of the stuff Richard talked about last week, just to fix ideas, picture aggregate output being a CS combination of different goods and elasticity of substitution sigma, and then this linear production, so output is linear in labor. So for simplicity here, just one factor, but I'll elaborate on that in a bit. And then this is like process efficiency. But in this CES setup, I could have put A here. So A, it turned out, would look identical, whether it's like quality, some sort of demand shifter, or process efficiency down here. And I'll return to that in a few slides. So picture a firm, a monopolistic competitor. They're monopolistic in the sense that they set their own price, but they're a competitor in the sense that they take the wage, aggregate output, aggregate price, everybody else's prices as given. They view themselves as atomistic. So it's like one firm per variety, for I, per good I, intermediate good I. And then picture, for simplicity, just a fixed total supply of labor to be allocated. So the only allocation decision in this economy is how to allocate the production labor to these different I goods to be produced, intermediate goods to be produced. And let's, for simplicity, fix L and fix the number of varieties or goods in this economy. And then what you get out of this model is price is a markup as a function of this elasticity of demand of marginal cost, but the revenue tax, which I should have dwelled on. So picture for the moment, just like a firm-specific or product or good-specific revenue tax rate, tau y. And I'm going to dwell on that at length, all the ways in which you might have wedges that look like taxes, but aren't actually government taxes and subsidies that might do as much damage as the taxes and subsidies that I'm describing here. Okay, so the firm, though, will price in that revenue tax rate. It's as if it raised its marginal cost. So right there, you get that it would have been isomorphic to put a tax on their inputs. In this model, just a single input, labor input, if you tax their labor input, that's the same as taxing their revenue. In terms of, it's effectively in their first order condition, like increasing their marginal cost, and it'll get flowed through into their price. So that will affect the allocation of labor, because if they have a higher price, there'll be less demand. If I go, look about the upstream demand curve, demand's going to be inversely related to this output. I should have written down the inverse demand curve, but I think I'll have it in a later slide in a bit. So the higher the tau facing some I, the less labor will be devoted to it. Okay, so one key thing here is that notice that TFPR, which was revenue divided by inputs, is not, or is proportional to the tax rate here, and is not equal to the underlying efficiency, which is sometimes called TFPQ. So TFPR for revenue productivity, or revenue relative to inputs. And that, in this simple example, there's no information about, in revenue productivity, about underlying productivity, because PY over LI will only pick up this term. It won't show AI at all. And that's because in this special case, there's perfect pass-through of process efficiency into price. 1% higher AI means 1% lower price. That's AI shows up inversely in the price here. So when you multiply PI times YI over LI, which has AI in it, the AIs cancel. So you get something that only involves this idiosyncratic tau. And the reason I'm dwelling on this is because it has far-reaching implications. Even though this is a special model where TFPR says nothing about efficiency, even more generally, it's not going to be the same as underlying efficiency. So you really want to separately identify some underlying efficiency variable from some revenue productivity variable. And here it's showing that the more you tax firms, the more they'll look productive in this simple economy. And that doesn't necessarily reflect on their A's at all. It just reflects they'll have higher revenue per worker. That might be a sign of a distortion in the economy rather than a sign that the firm is really efficient. Of course, in richer models, there could be a correlation between TFPR and AI because of things like AI not flowing inversely into price. So things like variable markups, and I'll talk about those. But still, the broader point is really worth stressing here, this difference. And the first people who emphasized this terminology were Foster, Halterwanger, and Severson, who were really distinguishing revenue productivity from kind of quantity productivity. They called it TFPQ. So I'm borrowing and building on their terminology here, which is very clarifying. Okay, so aggregate TFP in this economy is like this generalized mean of the efficiency, the productivity variables, and then these wedges. And then you can't see it from just staring at this, but if you maximized, tau is some weighted average of the tau i's. If the planner just wanted to maximize this, they would set all the tau i's equal to tau. They would get, this is just like sand in the gears. It's just distorting the allocation. This is a special economy where everything's efficient without these taus, so the taus just do damage. So the best thing to do would be to not have them. But one thing that you can get from this simple example, and I'll add something on top of it, if you do log normally joint distributed A's and taus, and these are the means and the standard deviations of these A's and taus, and here's their correlation, then in that special case, you get, aggregate TFP in the economy, the log of aggregate TFP is a function of the mean A, and it's, also a function of the variance of A, because you get, variance is good when sigma is greater than 1. You can allocate more labor to the high efficiency firms. So that's a positive. But this whole term here, that's just coming from here. That's just coming from the generalized mean of A. That's what these two terms are. This is the unweighted mean of A, and this is like the weighted mean that you're going to get because you try to allocate more labor to the more efficient firms. And the key misallocation term is this, which in this log normal case in the CES economy comes out really nicely, where it's the variance of these taus that does damage, and how much damage is increasing in sigma. So the closer substitutes these goods are in this economy, the more damage idiosyncratic wedges do, idiosyncratic distortions do, because labor will respond more heavily to it. So labor will be reallocated more strongly in response to a certain wedge, the higher is the substitutability. So that's one key thing. And then if you wanted to put numbers on this and say, in the US economy, sigma squared tau was 0.5, then, and sigma was 4, you say sigma squared, let's say sigma tau is 0.5, so sigma squared is 0.25. Let's say sigma is 4, that's the substitutability between varieties, say. So you multiply by that 2, you'd get a 50% drop if you saw a 0.5 standard deviation in revenue per worker, because remember TFPR and tau is proportional to revenue per worker in the simple economy. If this was varying, the standard deviation of this across firms or across plants was something like 0.5, which is not far from what people get in various studies, then we're saying 4/2 times sigma squared is 0.25, so you get 0.5. So we produce half as much output, or minus 50% as much output as we could if we perfectly efficiently allocated labor to the point where we could equate labor per worker. And of course, one of the things that Richard brought up that I'll talk about too is that maybe this isn't misallocation because some of that dispersion is unavoidable. Some of that dispersion is from transportation costs or adjustment costs, so the planner really can't reallocate from some of those low revenue productivity, low TFPR to high TFPR. So that becomes a really important issue when thinking about whether these gains are achievable, whether gains from limiting this is even achievable or feasible. And then there's issues like, is there something wrong with this specification, this simple model? And what will altering some of those simplifying assumptions, what will they do to how we infer how much damage is being done from a certain amount of dispersion in TFPR? Okay. All right, so I've actually talked through some of these lessons already as I was going, that, the wedges show up in TFPR. TFPR isn't TFPQ, so really be careful about using this as a proxy for this. And there's really a whole generation of productivity research that did that. And so every question that people did in that generation of productivity research that was using this as a proxy for TFPQ should be revisited. An example is a paper by like Nico Voigtlander and a collaborator, which basically says, let's think about whether exporting allows firms to learn how to produce better. Let's examine it not in terms of TFPR, but in terms of TFPQ. And they found much stronger evidence for that in TFPQ than people had found previously when they were looking at TFPR. If TFPR was like a tax or a markup wedge, that might be stable as you enter export markets, but you get a lot bigger. And when you got a lot bigger, that's a sign that you might have improved your efficiency. There might have been learning by exporting. And that was uncovered when they focused on TFPQ, which was the underlying efficiency rather than this TFPR. Okay, so Other things I stressed is TFP is decreasing in the dispersion of these wedges. And as I mentioned, more so the higher is sigma. Aggregate TFP in this static model is unrelated to the mean wedge, but in other models, like if there's free entry or there's investments in quality, ongoing R&D, then the mean wedge will start to have dynamic implications. So that's just a simplification here that the mean wedge didn't do anything at all. And then I'm just mentioning that dispersion is increasing that aggregate TFP is increasing in the dispersion of TFPQ. That's kind of an interesting question related to misallocation, because if the TFPQs themselves, their distribution is endogenous to the misallocation, then misallocation could be affecting the economy through its effect on the distribution of this, and therefore the gains. Like if you had, borrowing from some work by Bento and Restuccia, if you have a bunch of firms with really small productivity that enter because of lots of barriers to becoming bigger, say in India, then you might see less dispersion of TFPQ, or less than the right tail of TFPQ, or maybe more dispersion, because maybe a few big firms that are efficient and you have a large number of small inefficient firms. So you might have more or less dispersion of TFPQ as a result of policies there. So that's important for taking a full picture of the effect of misallocation. All right. So I wanted to kind of have an aside on how to think about getting data on TFPQ. So the output here, you can infer, put a sub I on that, you can infer from inverting the demand curve. So the restriction is you need to know the demand curve. But if you know, a CES demand curve, or if you knew the firm elasticity, if there was a variable elasticity world, you could infer the firm's effective output from its revenue, something proportional to that, by just inverting it using the elasticity in this demand curve. And again, there could be a sigma I on this. And one thing I really want to emphasize is, remember when I set it up, I said the AI, I could have put it in quality. What you'd back out here would be quality as well as the quantity of what they're able to produce. Because what generates revenue for a firm is not just like how many cars they produce, but how good those cars are. Like, nobody really cares if people produced 1 million Model Ts from 1900 now in the US market. They'd have really high quantity productivity, but the quality would be so low that there wouldn't be much demand for it. This Y should capture what we really care about, which is this composite of quality and quantity. And so then when you think about dividing this Y that you've backed out in this way from some measure of inputs, and again, you can generalize inputs beyond just one here, keep in mind that you'll get at not only process efficiency, but quality. Okay? And the reason I stress this is because sometimes people say, well, if you don't have data on unit prices, then you're stuck. And I'm saying, no, actually, you're stuck if you're trying to get at process efficiency that way, because you really need units of output, quantities of output divided by inputs to get at process efficiency. But if you wanted to get at a composite of process efficiency and quality, which is broader and therefore in some ways more valuable, you can get that just by inverting the demand curve. I say just, that can be hard to figure out how to invert the demand curve, but if you have a method for doing that, that will get you a composite you do really care about. And if you do on top of it, in a subset of data sets, there is data on physical quantities, so you can get average unit prices from that too. But if you can use that physical quantities, let me say I call those QI, and I'm distinguishing that QI from this YI, which would have quality in it. So this is just physical quantity. Then you can infer process efficiency from that. And that might be separately interesting to figure out, are firms high quality? And you infer the quality from the difference between the TFPQ and I should have said on the process efficiency here, the TFPQ versus QI over LI here. So the difference between those might reflect quality. Okay. And again, my prior is a lot of firms compete on quality and not on pure just like price of, we see tons of dispersion in price, but we also often see massive differences in sales for similar prices. And also some of the high price products and firms have really high sales. So that would be inconsistent with inequality differences if they had higher price and yet higher sales at the same time. So I think there's plenty of scope. The data telling us there's plenty of scope for quality dispersion, not just process efficiency dispersion. Okay. All right, so this was a simple model. And Richard touched on some of this stuff. It's easy to generalize to physical capital. It's easy to generalize to intermediate inputs. I think that came up in a question last week. My recent paper with Mark Bills and Kian Ron, who's here on the Zoom as well, we explicitly brought in intermediates, and I'll talk about that in a couple slides. You can put wedges not just on revenue, but on all inputs if you want. As Richard mentioned, you can't distinguish like a common wedge on labor, capital, materials versus revenue. Those will look the same in terms of firms' decisions. So it's kind of like you can identify a common wedge that affects all inputs or revenue, and then relative wedges that affect like capital relative to labor, labor relative to materials, and so on. And then another thing that's easy to bring into this model is overhead costs. And Bartelsman, Altuari, and Scarpetta are an example of doing that. There's always the challenge of like how big are overhead costs, but if you had some information or way to infer them, you can easily adjust for them, in which case you'd back out these taus, not from TFPR, but from a kind of overhead adjusted TFPR. You'd subtract overhead inputs from the inputs that you had in the denominator, and then you'd get a measure of TFPR that was closer to the wedge that we're interested in. But they're certainly right in pointing out that if there are these overhead costs, that what I defined as TFPR as revenue over inputs would not totally reflect the wedge. It could also reflect these overhead costs. You can also think about relaxing the assumption that entry costs aren't, that entry is fixed. And Dinger and Morrow is an example of a nice recent paper that I'll touch on later too. Okay, so harder to do in the sense of like, you have to start modeling dynamic decisions. These generalizations can all be done with static decisions. Like if you assume that the fixed amount of capital is being allocated at a point in time. All of these things stay within a static framework and very tractable. Here you're starting to deal with dynamic decisions or things that aren't closed form solutions anymore. So these are the dynamic ones, financial frictions. That hasn't stopped a lot of people from doing that. Joe Tabosky, for example, one of the leaders in bringing this in and finding significant amounts of misallocation as a result of financial frictions that made some firms with really good productivity, but not the internal financing to be able to combine it with enough physical capital. So if external financing has constraints, that would put sand in the gears of allocating capital to the firms you really want to have the most. Okay, so people have done adjustment costs. I'll talk about this paper a little bit, and also David and Venke, which is a more recent one. That CES, that's special. You can imagine doing variable elasticity of substitution. I wish we had like a consensus on what was a good description of demand, like whether it was some particular VES with some particular functional form or parameters was considered a good approximation. But I think the literature is still exploring alternatives and seeing what they do. So I'll talk about those a little bit. You can also say, what about the single inputs that feed into output downstream? What about, the car industry uses steel and all these other inputs, and then cars that can be used as inputs into making steel, et cetera. So, general input-output structure. Fortunately, there's this beautiful paper by Bakai and Farhi that treats a very general environment in terms of input-output, and in terms of things like constant returns to scale, which I was imposing. And then there's all kinds of interesting issues. This is more of a dynamic thing, like I was mentioning, where you endogenize where the TFPQ is coming from. So instead of taking the TFPQ distribution as fixed, and the taus kind of impact the allocation of resources, capital, labor, et cetera, to the different firms with different TFPQ. Instead, firms' investments, as I was mentioning, in TFPQ are a function of that. And Bento and Rastusha is one of the leading papers on that. Okay, so that was my kind of introduction and simple model and getting out some simple ideas. Now I want to talk about, I've already touched on some examples of misallocation, but I want to be explicit about some more. And then I want to talk about the 5 fact patterns after that. Okay, so first, what is not? Before I give you examples, what are things that are not misallocation? Even things that would generate TFPR dispersion that aren't misallocation by my definition. Well, anything that's just measurement, anything that's just like they made an error in recording revenue versus inputs, maybe the true economy perfectly equates TFPR and the value of the marginal product of labor or capital across firms in the economy, but then when we measure it, it doesn't, but that's just because of errors in the way things are recorded. That clearly wouldn't be misallocation, so we clearly have to worry about that. And my paper with Mark Bills and Kian Ron is precisely about that. So another one is adjustment costs. I'll mention that, a couple of papers in that literature as I promised. Another thing I haven't brought up though is differential risks. Maybe rate of return on capital is systematically higher at some firms or in some industries than others, that might be misallocation, or it could be that's just riskier. And so perfectly functioning market is requiring a higher average rate of return to compensate for the systematic risk that's higher in those firms or those sectors. So that in general, people need to worry about. Could be compensating differentials. If you looked at the value of the marginal product of labor, you could even do this for the same worker. My colleague Isaac Sorkin has studied that, which is, workers may voluntarily move from a low-wage firm or high-wage firm to a low-wage firm. And you could say, wow, the same worker had different marginal products and wages. So if the same worker has different wages across different firms, that you might say that's evidence of differences in their marginal product and therefore misallocation. But you have to be careful on that one. There could be workers may be indifferent between these firms. The marginal product may differ, but the amenities, the disamenities may differ across those firms. So I think this is the ripe area for people to study. To what extent is labor misallocated versus there's just amenities and disamenities that have to be incorporated. And then I think this came up in Richard's thing too, which is imagine that it looks like the capital labor ratio differs across firms, even within a narrow industry. You could say, oh, that's a sign there's misallocation, because if they had the same technology and face the same factor prices, same capital intensity of their technology, then they should have the same capital labor ratios. So maybe they have different costs of capital, for example. So an alternative is that, the one that has a lot of high capital ratio, labor ratio, just has, a more capital intensity in their production. The production, picture Cobb Douglas, and they have a bigger share on capital. So then you have to worry about that would generate lots of dispersion in these naive TFPR measures that aren't really reflecting dispersion in the value of marginal products across these. That's the key idea in misallocation, is if there's dispersion in the value of marginal products, then there's some gain that can be had by reallocating inputs from their low value of marginal product uses to their higher value of marginal product uses. And these are all saying, be careful, this would be, it's imaginary, it's illusory, those gaps aren't really there. This is saying you can't realize those gaps because there's costs to move those inputs. This is saying there's risk that those gaps are compensating for. This is saying there's amenities to workers that those gaps are reflecting. And this is saying you're not measuring the gaps in marginal products properly because they're not going to have the right production function.
Pete,
Yep.
may I jump in here? So
Please.
when you're ruling out transportation cost as a misallocation, you're implicitly assuming that transport infrastructure is perfectly provided everywhere, right?
No, just the way I wrote it may made you think that, though. So I'll have a later slide that says there can be misallocation of investment in infrastructure. Absolutely. I'm saying, think about like conditional on efficient allocation of transportation. Just the existence of physical transportation costs would mean that there'd be some wedges in the marginal product. But I completely agree with your point that there could be misallocation in infrastructure investments.
Thanks.
Yeah, okay. So I'll mention that again in discussing the Oscar Collard Wexler DeLacker paper. Okay, so what can generate, misallocation? Examples would be, literally tax rate differences across firms. In the United States, there's plenty of special tax rates for big firms versus small firms, but also whole sectors that get special tax subsidies. Economists love a carbon tax, but in the real world, we have a carbon subsidy, at least in the US, which just seems kind of crazy. So lots of size-dependent regulations. In fact, long before Restuccia and Rogerson, there were papers like Oppenheim and Rogerson that talked about firing restrictions and how they would misallocate labor, in a dynamic model where workers were moving across firms subject to these dynamic costs. So there's been a long history, people like Nezzy Gunnar and other people studying. This is what Richard was calling the direct approach, which is you take an observable policy and then model what it's doing and provide evidence on what it's doing and figure out how much misallocation that might be generating. Whereas you'll notice that a lot of what I'm doing is very much from what he called the indirect approach, which is let's look for all these gaps in values of marginal products. And that's evidence of all types of things that might be contributing to misallocation. So our approach was like, how much room is there for misallocation? Is this big? Does this add up to a big number? Restuccia and Rogerson pointed out that it could be big, in their model economy. And we found there's evidence consistent with it could very well be big. So if the gaps in the data were really small, we'd be saying theoretically, that can contribute to big TFP differences, but we don't see any evidence consistent with that. Instead, we found plenty of evidence opening up the possibility of large amounts of misallocation. But this direct approach that started to look at things like size-dependent regulations preceded this kind of indirect approach, and it continues. So there's like the stuff by Luis Garicano, Claire Lalarge, John Van Reenen about size regulations in France seeming to have a big effect as an example. Okay, so one category I really want to emphasize, because I think it was a confusion for some reason, is that price markup differences across products, that's generating misallocation. Okay, that this may seem obvious because we always think about the monopolist charges too high a price above marginal cost, the competitor charges price equal to marginal cost. The planner wants the monopolist to produce more. They don't want them to, they don't want consumers to substitute away from something. Imagine two firms with the exact same marginal cost in different industries. One has a big markup, the other doesn't. We have too little of the markup good. From the planner's point of view, we want to equate the consumer decisions to the marginal cost. We want the marginal rate of substitution on the consumption side or the downstream demand side. We want that to be equated to the marginal rate of transformation. So we want the marginal utilities or downstream marginal products to be equated to the relative marginal cost. And markups are like a wedge in that process that distorts it. It means that if Apple's markup is bigger than Samsung, we don't have enough Apple smartphones and we have too many Samsung smartphones. So there's some gain to reallocating it until those values of the marginal product are equated. And I stress this because I think some people reacted that, government imposed distortions, well, that's inefficient, but if it's profit maximizing behavior, that's efficient. Well, no, of course, this is a market imperfection. This is just because it's profit maximizing doesn't mean it's not distorting. And the same thing goes for markdown differences, and there's growing interest in that. There's a paper by Berger and Herkenhoff and Mungi that emphasizes markdown dispersion and how much misallocation it can cause, for example. Okay. There's other things. Sorry.
Can I ask you a question in terms of the price markups? So you said that this can generate the misallocation, but in terms of, for instance, your 2009 paper with Xie, using the framework of CES aggregator, so the markup is the constant under this framework. How are you able to generate markup differences related to misallocation in your framework?
Yeah, that CES one would not generate it. If you could either deviate from CES, so variable elasticity substitution, or we had monopolistic competition, you could keep CES and put in, Cournot, for example, rather than monopolistic competition, small number of players within every subsector, and then their market shares would feed into their markups. The bigger firms would have higher markups because they'd have a lower elasticity they'd face, and the smaller firms would have a lower markup. So some combination of changing the market structure away from monopolistic or changing the preference structure away from CES. And so people have done that quite a bit. Yeah.
Thank you.
But I will emphasize that it's not isomorphic to what we did. That saying one could change some of the assumptions and get lots of misallocation due to markup dispersion isn't the same as saying that what we measured as wedges, they might be markup, they might be fine under those alternative models, but the misallocation we got, the deadweight loss, the Harberger triangles we aggregate up to might be different because the economy is characterized by variable elasticity of substitution. So I'll touch on that a little bit later. That's an important issue I wanted to convey. Okay, so there's also like not just thinking about a generic worker allocated across firms or how many workers are at this firm versus how many workers at others, but which people. And you can imagine discrimination any number of places. And the reason I emphasize this is because I feel like there's an enormous literature on whether wage gaps reflect discrimination and looking for discrimination in things like housing, or mortgage loans and other loans by banks. And I think I understand that we're obsessed with this because we want to know how much discrimination exists, and it's unfair, right? It's unjust. But what surprises me from, I'm an outsider to this literature, what surprises me is that there's less emphasis than I thought there would be on the efficiency aspect of it, that it means you're misallocating labor if the people with the best talent aren't the ones admitted to the graduate school or aren't the ones admitted to med school, aren't the ones hired for certain jobs. or don't get loans for housing. So if there's discrimination against the Black population in the US in loans, or business loans, that's going to mean there's misallocation of who's entrepreneurs and who's in houses. And that's an efficiency loss. So the misallocation literature comes naturally to that of saying not only is there a distributional implication, but there's a size of the pie implication as well. It's an efficiency loss associated with that. So it's unjust, increases inequality, and on top of that, shrinks the pie. Okay, so I'll give you an example of that in a bit. We already mentioned some financial frictions, but you can also think of state-owned banks or a government wanting to favor certain firms that are politically connected as a way of maintaining power. That seems like it's true in the United States. So I think it's found to be true everywhere and every time, just to varying degrees. Efficiency wages haven't got as much attention. There's a lot more attention on firm monopsony power recently, but efficiency wages generate misallocation too, right? If some industries have to pay higher wages to try to induce people to put forth effort in the presence of a asymmetric information problem, then that means there's too little labor in those firms and in those industries. Now, this might run into what I was alluding to earlier, which is, can the planner really improve on it? And it turns out they can. If the planner knows this set of firms or this set of industries is plagued more by asymmetric information than another one, if it subsidizes the high efficiency wage firms and industries, that'll actually improve allocations. Even though it's kind of counterintuitive when I first started seeing people do this, but it's true in some of those models. Okay, so lots of government policies like licensing, entry, land use restrictions. This is what I was alluding to earlier to the question. There could be under or over investment of public spending on things like R&D and infrastructure that itself could lead to misallocation. And then any externalities, positive or negative, are something that lead to misallocation. Once I start listing this, you see what I said at the outset, which is misallocation is just what economists do, is we study the efficiency of the allocation of resources. So that's why basically any decision that's made, I'm saying that could be misallocated. And we have to think about why it might be and quantify the effects of that when we want to think about how we could improve welfare, improve policy.
Sorry, Pete, I have a question related with this under or over investment of R&D. Previously, you mentioned that misallocation is not the result of being successfully, to develop successfully technology or not. But as I see, if you look at the thing at a moment as a firm at a moment of time, you will tend to, I expect that you will tend to value as more productive firms that were successful into developing some new technology or whatever. So if you look at the picture, like at the picture at the moment of time, you'll say, okay, so the idea will be to shift some resources from this firm to this other firm, but what you're doing is observing just a successful entrepreneur, let's say, that you cannot know ex ante.
You can't know ex ante. So if there's adjustment costs that like the markets didn't know to allocate more resources to Elon Musk, or because they didn't know how successful, we still don't know. There's still a big bet there on how successful Tesla will be. But you're saying we don't know ex ante, ex post, some of these outcomes are much better than others. I view that as a version of the adjustment cost story of we couldn't have known ahead of time. It was real information realized after we had to make these loans and this allocation of resources. Some of them will pay off higher than others.
But can be adjusted for that? Is it been done to look, I don't know, a sequence of firms doing investment and to check whether some of the misallocation in T+10 is just a story of being unlucky?
I would say yes, in the sense that when people have said adjustment costs should have very transitory differences in the marginal products of capital, whereas things like in financing frictions too, for that matter, whereas things like markup differences might be more persistent or could be more persistent. So one of the facts I was going to touch on is that there's lots of evidence. It's going to be one of my 5 facts. Is there's lots of evidence that most of the TFPR dispersion is persistent. So that would say, yeah, then we should have figured out this was a good entrepreneur. We should have allocated them more resources by now. This is 5, 6, 7 years worth of seeing the firm continually. But that is really important. What you said is to separate out to the best we can the transitory stuff that we couldn't have allocated resources better ex ante versus the, ex post where it's just kind of stuck, versus the stuff where it's like, well, it looks like it's persistent, so maybe the market should be allocating more. Yep.
So some data I'm checking, it's actually goes with the line what you say. Usually, I see like a lot of persistence in being successful doing R&D. So yeah,
Okay.
I guess. Thank you.
Yeah, yeah. Okay, I just wanted to tell you about this one study with Kang Taishe, Eric Hurst, and Chad Jones. We were just looking, facts that are qualitatively very familiar to people, which is that if you looked in 1960 and we had these high skilled occupations, which you define either by education or wages, they look very similar. We excluded social scientists. That seems too self-referential and claim that they were high skilled, that we are high skilled. And then in the United States in 1960, you might wonder where Hispanic in this. They're in the black. There's black Hispanic that are in black, and there's white Hispanic that are in the white, as well as the non-Hispanic, because it's not estimated in a consistent way across time in the United States. So we couldn't break that out continuously. So it's just included in the white and black respectively. And then other groups like Asian and Native Americans. Asian Americans and Native Americans, those are too small to kind of go back to 1960 and look at these fractions. Especially Asian Americans have grown a lot, but that's why the study focused on white versus black. Okay, so 1960, you can see white men were about 40%, so white men were over 90% of these occupations, even though they're only 40% of the population. So you can see of white men, almost 20% of them were in these high skilled occupations, and just far fewer white men and black women, even as a share of full-time workers among these groups. So even this doesn't even take into account the fact that women were much less likely to be in the formal labor force. Even the ones who were full-time, so ignoring part-time, ignoring out of the labor force, they were just much less likely to be in these high-skilled occupations. That's changed dramatically. This is even more recent than we had in the paper, but in the paper we stopped at 2010. It was a 50-year period, but most of that occurred in that 50-year period. Just dramatic equalization. It's not perfectly equal. There's plenty of room for further equalization, but our interpretation of this is the efficient thing would be for all these numbers to be the same. They were very inefficiently different in 1960, suggesting differential opportunities either to acquire skills or to, once they hit the labor market, to get those jobs. Or by 2010 or 2018, there might still be discrimination, but much less. And so the thing that we're adding relative to an enormous literature that was documenting these differences in occupations and wages within and across occupations is asking what's the output impact of this? What's the efficiency effect of this? So we put these wedges in that hit women and Black Americans more than white, and then we have them fade over time. And they're occupation specific, so they're in big barriers to becoming a lawyer or a doctor, and lower barriers to becoming like a nurse or a teacher, say, for women. And because of comparative advantage, that's a critical ingredient. In our model, it really matters who's the doctor and who's the nurse, who's the teacher and who's the lawyer, because people have different skills for that. And you might ask, how do we know that? Well, we use the fact that there's a lot of dispersion in wages within occupations. And you might ask further, well, maybe that's absolute advantage. Maybe the person who is an awesome doctor would have been an awesome nurse as well. So it really doesn't matter whether that person became a doctor or a nurse. You could switch them around, it wouldn't matter. But one of the things that labor economists say is that people who transition between occupations are disproportionately the lower wage people within every occupation. That's suggesting the people with high wages in that occupation have a comparative advantage in that occupation. So then it matters who is a doctor and who's a nurse. And so because of that, we get enormous gains from this equalization of opportunities. And a bunch of that, when we look at GDP per worker, it's smaller. And you might say, how's it so much bigger here? Because a bunch of it is due to rising labor force participation rates for women. We're saying women face less discrimination in the labor force, so that caused them to participate more in the labor force. And that generated some of this rising workers per capita that fed some of the US growth. But even GDP per worker, we're saying 1/4 of it over a 50-year period. You can ask, is this repeatable? On our metric, we only say another 10% increase in GDP per worker can be achievable, but we're missing lots of things. Like in our model, how good you are. And so whether you should be a doctor, and the best ones, the best women and Black Americans in terms of their talent to be doctors still become doctors even in 1960, Whereas in 2010, we get more of the marginal ones in that are better than the white men who are crowded out. But so there's an efficiency gain to that. And they accumulate more human capital because there's less barriers to that along the way. But that framework kind of ignores differences in just opportunities early on. You know, are we missing people who should have been a doctor? You know, Jennifer Doudna, one of the inventors of CRISPR, you know, other Jennifer Doudnas we've missed because they just never were encouraged anywhere along the way or given opportunities to go down the research path. So our model could be underestimating both the gains we've experienced historically and the future gains, especially if you look at research, because that's looks more like 1960 representation by race and gender rather than 2018 distribution by race and gender. So it looks like there's, you know, if you count inventors or you count professors, inventors like patenters, it looks like there's tremendous opportunities for equalization there that should make for more research and more higher quality research output. Okay, so so that was a bit of a digression into, hey, let's think about, instead of allocating inputs across firms or plants, let's think about which workers do what. But there's lots of areas that people have already started to do to in this direction. So, you know, discrimination by gender, not only in the US, but other places, and of course, discrimination on things like caste or other observables. Okay, let me skip over this. I guess this is just talking about under what circumstances TFPR reflects average products, and, you know, pointing out we need some strong assumptions to go from average products to marginal products. We need Cobb-Douglas, and to go from marginal products to marginal revenue products, you'd need equal markups. Okay, let me move on from that. So one aside is just to say, and I think this came up in Richard's talk, which is, what about gross output versus value added? So one thing is you get smaller TFPR dispersion if you do it relative to gross output than value added, but distortions are amplified. Chad Jones has a couple nice papers. Ernest Liu has a nice recent paper. Bakai and Farhi, I already mentioned their very nice paper. And that's a bunch of what my paper with Kian and Mark Bills is about. So part of it is that intermediates are a multiplier, like Chad said, and part of it is this double marginalization. That's in Ernest Liu's paper. He emphasizes distorting upstream firms and sectors is really damaging relative to distorting like final goods sectors. And that's an ingredient in Bakai and Fari too that I'll return to. Okay, so now I can do, in the remaining parts of the main lecture part, I want to make sure I talk about some patterns I see in the recent papers on misallocation. And then if I have time, I'll talk about some data sets, but they'll be in the slides as a resource. And also, if I have any more time, I'll talk about some more recent papers in more detail. Okay, but I wanted to get out these five key facts. So one, which I've already kind of implicitly said, but I want to be explicit about, is that people are consistently finding more dispersion in this TFPR in developing economies than in advanced economies, in the richer economies. And that's consistent with misallocation not only being large and important, but being a bigger problem in developing countries than in advanced economies. So it's a problem everywhere, but it seems a bigger problem in developing countries. So that's what makes it very much a macro development question, that it helps us understand. Yep.
I have a question. Sorry for interrupting. What about this misallocation by size? Like if you split like very big firms from small firms and you compare countries? I'm curious about that.
I mean, I'm going to touch on that because I'm going to say TFPR is strongly increasing in TFPQ, and I'm going to argue that's going to make firms much smaller and plants much smaller in developing countries. That the fact that this is steeper in developing countries than in rich countries might be contributing to why average firm size is so different. Is that what you're alluding to?
The thing is, the other day I was discussing with a professor something that happens in Spain, that when you look at firms that are above 50 workers, things in productivity really look like other European countries. But when you look at below 50 workers, you know, is where things get really messy. So I was wondering if you have some idea of how developing countries and developed countries look like in terms of the relative, I mean, possibly relative misallocation between big firms and small firms. Yeah.
Yeah, I think this is going to be related to the fact too. So let me come back to that shortly,
Yeah.
and I'll even have some discussion about why that might generate some of the facts that you're talking about.
Okay, thank you.
Okay, and then Most dispersion is in this fixed effect. So as much as we care about, misallocation of capital relative to labor, or labor relative to intermediates, et cetera, it looks like there's a common component that's quite important. And this we touched on already, much of the dispersion, the cross-firm dispersion is very persistent, that it's not like the firms are IID in terms of which ones are the high and low TFPR, that the majority of the variance seems to come from a component that's like a plant or firm fixed effect. And then the last fact is that much of the dispersion in the average product of capital seems to be occurring even within firms, like especially in the United, this matters by country, but in the United States where you have a lot of multi-plant firms in manufacturing, then you can analyze this and say, is most of it, if we had a single plant firm everywhere, then this wouldn't be meaningful. But in the United States, there's a lot of multi-plant firms, and we see a lot of dispersion in their average product of capital. So then that becomes interesting. What can we learn from that? Okay, I think Richard already showed you this plot, which is just TFPR dispersion in the US versus China versus India, so that it's significantly smaller. And so if you do, like, he also showed you a table of like the 90-10 ratios. So you want to think about 90-10 ratios that might be like a factor of 2 or more. So say if the 10% marginal product of capital at the, let's do the 25th versus 75th percentile. So the 10% marginal product of capital at the 25th percentile, there might be a 23% marginal product of capital at the 75th percentile firm. So we don't need these enormous differences in marginal products of capital or marginal products of labor. Similarly, like saying the same worker had a marginal product of labor worth $10 an hour at one firm, but worth $23 an hour at another firm. And that's like the interquartile range of firms that we see. We don't need an enormous amount to generate a lot of misallocation. Of course, what matters also is that how substitutable these firms' outputs are, but, as I mentioned earlier. Okay, so when people add it up, there's Bakai and Farhi. I was quoting a 40% number for the US. They get a 20% number, maybe 25%, depending on the version you look at. They were looking at these very big firms. So the 40% number I was quoting was for like manufacturing, which had a bunch of smaller firms in it and was only manufacturing. So CompuStat has a lot of non-manufacturing, but it's also the publicly listed firms. So I'll dwell on this a bit, why it's so big in a bit, but we found something bigger for manufacturing, but then even bigger misallocation in China and India relative to the US. And I think people touched on as these things changes over time. As Richard said, we found a lot of reduction in misallocation in China, that we found that it seemed to account for about a third of their growth, their rapid growth in manufacturing over the period we were looking at. And about 40% of that was due to state-owned enterprises that were very inefficient, had very low TFPR, either exiting or being privatized and shedding a bunch of inputs, and their TFPR coming back up toward the mean. So China is kind of the best case because we can see it actually change over time. So it doesn't look like a pure measurement problem, and we can see it change. We see the sources of it seem kind of sensible, which is these state-owned enterprises. And when the state-owned enterprise faded, it looks like the misallocation, was diminished as well. And they experienced rapid growth over that time period too. So it all seems to hold together nicely in China. India less so, because it looks like there's massive misallocation. They've grown pretty well, but it doesn't look like the misallocation as we measure it has actually fallen in manufacturing anyway. So the Inter-American Development Bank has a nice set of chapters in one of its books that looks at the same types of calculations in a number of Latin American countries. And what they consistently find is a lot of misallocation compared to what people find in the US. Michael Peters has a nice paper on Indonesian manufacturing, where he focuses on markup dispersion as the source of this, and has a theory of endogenous markup dispersion. It's quite nice, as well as endogenous growth. And then Diego Restuccia with co-authors has many papers, but just a couple of them I'll mention here on agriculture in China and Malawi that find even larger losses in agriculture than in manufacturing. So we have a little bit of this, the drunk looks under the light post because that's the only place they can see. They look for their keys there. We have a little bit of that problem in this literature that most readily available data is manufacturing. So the vast majority of studies are about manufacturing, but it could be there's more misallocation outside manufacturing. So that's what Diego is finding with his collaborators in agriculture. Chang and I did something for Mexico that found something similar. In the service and retail sectors, we found more misallocation in Mexico than in the Mexican manufacturing sector. So it's kind of a frontier we've only started to explore, is what do things look like outside manufacturing, and why might it be different? It's interesting too. Okay, so an aside on Harberger triangles. So like when I mentioned that when I first saw Restuccia and Rogerson's big numbers, you know, like you tax productive firms and you subsidize unproductive firms, you get 30 to 40% loss in GDP. I was like, whoa, how is that possible? I remember the Harberger triangle, which was like monopoly distortions aren't that bad. You know, they reduce GDP some fraction of 1%, maybe well beneath 1%. So one of the things that's beautiful about this Bakke and Farhi paper, it's got a lot of nice things in it. Like I said, it's got general input-output structures and nice decomposition into technological change versus changes in allocative efficiency. It's got a lot of great things about it. On top of that, it says, what about this Harberger number? How can we get 20% more or loss of GDP from misallocation and market dispersion? And Harberger got far less than 1%. So they decompose it for us. And they say, look, wedges or these taus within industries are much bigger across firms than they are when you average them and look across industries. So you average out a lot of this dispersion when you look across industries. And when you look across industries just aren't that substitutable, right? Compared to like, you know, Samsung versus Apple smartphones, those are highly substitutable and the wedge differences between them are substantial. Whereas if you say, what's the average wedge difference between steel and cars, it might not be that big and they're just not that substitutable. So you get much smaller losses from those smaller wedges between less substitutable industries, and you get, you know, big wedges within industries and lots of substitutability within industries. And then they show propagation from the input-output matrix, which Harberger didn't have. So this is a very nice kind of saying why the recent literature is getting such big numbers, whereas Harberger got small numbers. Okay, and then there's also, I don't know where to put this because this also fits into dynamic effects of misallocation, but Jim Schmitz has been writing a sequence of papers that are really fascinating about misallocation due to monopoly in the United States. And it's really fascinating because it's not like this, you know, hey, it's like a tax in the firm and the firm just responds optimally to it. You know, its markup is its own tax. So you can think of not literally a tax, but like a firm deliberately just reducing its output and raising its price. He's saying no, they do things like put in work rules that are inefficient as a way to redistribute or distribute some of the rents that are within these monopolists that end up destroying value. So he's got lots and lots of examples of this happening, partly due to government regulation, partly due to, you know, industry market power, so partly due sometimes to, you know, union power and union decisions. But he describes it as a byproduct of monopoly power. So he's basically saying monopoly power can do much more damage if you carefully understand what's happening in these industries than our simple models suggest. So I highly recommend tracking down all of his stuff on this. Okay, so there's more TFPQ dispersion in India than China and the US. I won't talk about that much more. I want to talk about a couple other things. Okay, so fact 2 is TFPR is increasing in TFPQ, and more so in developing countries. So like in India, we found a really steep relationship. This is TFPQ of the firm relative to or plant relative to the mean. Here's its TFPR of the plant relative to the mean. You can see just a really positive slope. For every log point here, you've got like half a log point here. So the elasticity is about 0.5. The elasticity is still positive in the US, it's about 0.1, but that's dramatically lower. So then the question is why? Why is TFPR so steeply increasing in TFPQ in India versus not the United States? Is it because if you try to get big in India, there's bigger transportation costs, or there, you know, the transportation system doesn't work as well to try to scale up the size of your firm? Is it Nick Bloom stuff of, you know, you don't trust people outside your family to run plants or businesses that are at other locations from where you are? This is also in some work by Akshit and Akshit, Alp, and Peters. But people have built these into models like Bento and Restuccia did and said, look, if firms know that ex post, like say, imagine this is tax rates on the formal sector and low tax rates on the informal sector, just to have one explicit example, then that will make you invest less in high quality that would make you big and make you a target of those formal sector taxes. So that's just one force that would push you toward being informal. Another could be, if there's big barriers to being formal and big, and those firms are intensive in skill, maybe demand for skill isn't very high, so maybe supply for skill isn't very high. So that's all, and so then you have a lot of low skilled workers and a lot of informal firms. So they were a really nice paper for showing how you could have a lot of firms and Roberto Fadal JF has a more recent AEJ macro with that theme as well. Barriers on the big formal firms or the more successful firms will end up getting more firms of lower quality. So you can understand not only why firms don't get big, but why there's so many small ones endogenously as an outcome of that. And that's in some of Atkinson Burstein's early work too. But basically you can also argue this is pre-entry, this is entry, this is, this is quality of entrance, this is quantity of entrance. There's also what you do post-entry. Do you invest in getting better and expanding? Like in the United States, there's a survey of like, when you start a business, why did you start a business? An overwhelming majority is like, I just want to be my own boss. I just want to control. It's not like I have an idea and I want to scale up, right? But I suspect if you did the same survey in many developing countries, the fraction who are like, who just say, well, this is the only opportunity I have. This is the best, like the subsistence entrepreneurs. This, I can't get a formal sector job. I don't have the skills or whatever. I think that fraction might be dramatically higher. So I'd be interested in seeing those same surveys done elsewhere. But these papers are trying to go in that direction of trying to figure out whether this, what looks like a static distortion, has lots of dynamic implications for human capital investment, for firms expansion post-entry, for the types of firms that are created and to begin with, and how many firms are created to begin with. So these papers are going down that path, but there's plenty of road ahead, I think, to keep pursuing that and refining our understanding of these patterns. Okay, this is one thing I was alluding to, is that post-entry, the US is kind of an extreme. Post-entry in the US, they really expand. And half of this is like incumbents growing, and half of it is smaller firms exiting. And Mexico is intermediate, India is extreme and having almost no post-entry growth. If you start filling in with more countries, the US is an outlier on the upside and India is an outlier on the bottom side. So a lot of Western European countries are in here, for example. So the US looks unusual in how big the firms get, and India is unusual in how small the firms stay. But it's interesting that there's variation in this post-entry behavior across economies we need to understand better. How much of this reflects different misallocation in these economies. Okay, so I was mentioning the fixed effect component. I'll call that the scale distortion, and then distortions in capital relative to labor, I'll call those mixed distortions. I think this is terminology that Joel David and Venki Swar introduced, scale versus mixed distortions. They find it's mostly scale distortions. In my paper with Kian and Mark found the same thing. And then that's helpful because it says financial frictions may be important, but maybe that's not the dominant source of TFPR variation. Maybe you need something common like markups, measurement error, but also like tax and subsidy type behavior. So I think that's useful in guiding future theorizing and future empirical work. So the persistence I already touched on. Dave and Venki found that was the biggest component in China and India. I'm sorry, China and the US. We found it in our study of the US and India and US manufacturing. And again, to me, that says maybe not financial frictions, which would be transitory because you can save your way out of financial frictions, or adjustment costs, which should be transitory as well. So those might be important, but they might not be as important as things like markup differences or tax and subsidy differences across these firms and plants. Okay, and then lots of stuff is within firm. And one reaction to that, my first reaction to that was, well, it can't be financial frictions because if the variation in the average product of capital is across plants within firms, then firms should have an efficient capital market within the firm. They should equate the marginal product of capital across their firms. So their explanation, this Carrig and Vincent paper is quite a nice paper, is actually it is financial frictions, but it's interacted with adjustment costs. So the firm is saying, we can't raise external capital all right away. So what we're going to do is we're going to spread out like upgrades of our factories. If we have multiple factories, we can't upgrade them all at once. Even if that's the most profitable thing to do with no financial frictions, we're going to space it out. So spacing it out ends up generating more markup dispersion. But they're saying, hey, that's kind of good dispersion because at least it economizes on some of those external financing costs and adjustment costs as well. But still, there's other possibilities for this pattern. There could be differences in production technology that are persistent. There's some capital-intensive plants and less capital-intensive plants. And that would be consistent with why a lot of it's persistent, whereas it wouldn't be very persistent if it was due to adjustment costs. And it also could be markup differences. A maximizing firm could just choose to, for one firm's got more market power, one plant within the firm produces the product with more market power than another, they're going to persistently have higher value of their average product to capital. And of course, there's the possibility there's just misallocation. Like corporate finance literature is rife with the idea that managers don't perfectly allocate resources across their activities. And so it could be multi-plant firms have, misallocation just like the economy does across different firms. Okay, so I think I'll skip some of the discussion of some of the data sets, but that's in the slides as a resource for you to look at, and just start talking about some of my favorite papers in the literature. I've already touched on some of them, some of my favorite recent papers, but I think I have like 8 minutes left for the presentation, and then we open up for Q&A. So let me do a little bit of that, of some of that literature. So, okay. So one paper that I think is quite important, I'd like to see it updated and published in a nice place, which is saying, let's dive in and figure out how this data is created. And this paper says, look, the US Census Bureau cleans the data a lot. So maybe that lack of dispersion in the US was just a lot of data cleaning before we researchers ever got it. And maybe in India, they don't do that. That's the big question mark. Imagine India didn't do any cleaning and the US did a lot of cleaning. What they did, which is really cool, is said, let's look at the raw US data. And the raw US data is like crazy dispersion. So it's like, it would look like more dispersion there. And it's like, well, let's throw out some of the obvious errors in there and assume the Indian data at least does that. But they get, they don't get as much of a contrast between the US and India anymore. They still get a contrast, but it basically widens US dispersion. Now, there's another force to be careful of, though, which is that the Indian data that they're looking at, and that I looked at with Shay, was firms that are, 10, 20 employees or more. And it turns out the majority of workers in manufacturing in India are informal plants that are actually smaller than that. So this is a nice paper for illustrating, let's really think about differences in these data sets and the sampling of these data sets across countries. I remember Halterwanger, when he first saw Chang and I do China and India and the US, was like, you can't do this. These are different countries with different data sets. It's firm level data in China and then private firms above a certain threshold. It's a census of all plants in the US. And it's, a sampling of large, medium to larger firms in India. And the underlying size distributions are different, so the sampling coverage is different everywhere. We went ahead and made the comparison, but his point is well taken, and this paper embodies that. Let's think carefully about what's in these data sets and how we can compare them. So definitely keep that in mind. So my paper with Mark and Kian, so we're worried about measurement error, and so we came up with what we think is an interesting way to test for it, which is basically, you can think of it as in the cross section, some firms have a lot of revenue relative to inputs. Well, what do the first differences look like? If you have panel data, does the change in revenue divided by the change in inputs, does that look a lot like the high firms with high revenue relative to inputs? Do they have a high change in revenue relative to inputs? Or if it was purely measurement error, there might be no connection between those two. And we embody that with a regression of revenue growth on input growth, which don't think this is supposed to be structural. It's supposed to, because input growth is endogenous across firms. But it turns out, in the presence of a lot of measurement error, then this coefficient should be low when TFPR is artificially high due to measurement error. And we found that relationship to be negative in the data, suggesting there's measurement error. And over time in the US, it's increasingly so. So we argue that there's growing mismeasurement in the US, and maybe it's due to things like, compliance with the survey is going down. Firms, and the same thing that makes fewer firms respond may make them put less effort into their response. So there may be less careful responding in that survey over time, so growing measurement error in the US. So that's actually amazing, because if naively, it looked like allocated efficiency was plummeting in the US, and we get a modest decline, still economically interesting, but a modest decline. And so that's our attempt to go straight at the measurement error explanation, which would be the most undermining of, I think it's the most undermining of the possibility of misallocation, because it says it's just not there at all. Adjustment costs are different, as I hope I'll have time to say in a couple slides. Yeah, here. So this was alluded to multiple times by Richard and earlier today. So imagine there's just adjustment costs for capital and there's idiosyncratic shocks. That's going to generate dispersion in the average product of capital and the marginal products of capital. And there's nothing the planner can or should do about that necessarily. And so they provide some evidence for that there's bigger idiosyncratic firm shocks in developing countries. And that's leading to, even with the same adjustment technology, that's leading to more dispersion. So so I have two kind of reactions to that. One is that it still contributes, several reactions. One is it can still contribute to TFP differences. If they're right, then one explanation for the low TFP in developing countries is they have bigger idiosyncratic shocks that interact with adjustment costs. Again, we can't do anything about it, but now we understand some of that difference and where it's coming from. So we still learned something I think it's valuable. The second thing is you can ask, this is kind of similar to, I think it was Mateus's comment about infrastructure might not be efficient. Where are these firm shocks coming from? Why are there more bigger idiosyncratic firm shocks in developing countries than rich countries? Is it because they're small? In which case this might be a byproduct of whatever keeps firms small. Firms can be bigger, we might have less less dispersion in average products, and maybe less, or maybe we'll be able to produce more output because of it. The last thing is caution about data. You know, I've mentioned single countries because we don't have country, you know, samples for 50, 100 countries that are really comparable and really high quality. So they did the best they could using these World Enterprise Survey data so they could get many countries at once, but there's a lot of missing data in this study. So this is a question I think still needs further study. And David and Venki, maybe this is one of the last ones I'll mention in more detail. So I mentioned that they found a big fixed effect, but they also kind of poured some cold water on the adjustment cost explanation. And Richard alluded to this, which is they said, look, if you think it's adjustment costs, what you should see is the average product capital differences should be transitory, and the investment rate differences should be persistent. So it'd be like, you know, I get a positive shock that pushes up my marginal product of capital. It's going to take me a while to build the capital stock. So you should see capital growing continuously and the average product coming down, marginal product coming down continuously. So you should see the transitory behavior of the average product, but the investment rate should be serially correlated. They don't see much serial correlation of the investment rate. That wasn't a moment that Asker, Collard, Wexler, and Docker looked at. When they do look at that moment, they don't have much role for convex adjustment costs. Now you could say, what about non-convex adjustment costs, like the kind Carrig and Vincent were analyzing? They said, well, then you should see a lot of inaction, a lot of volatility of investment. We don't see that either. So in the end, they end up saying, yes, there's adjustment costs. Yes, adjustment costs contribute to some of the dispersion in these average products in the US and in China, but it's not much of it. It's like a sixth of it rather than the dominant role that Asker et al. Were giving it. So they find some sort of other big fixed effect in this average product, and things like markup dispersion might be important for that. Okay, so I already mentioned the Carrig and Vincent, I think. And this is a paper by Amit Saru that's talking about whether this dispersion in TFPR, not just in the average product of capital, but in TFPR more generally across plants within the US, whether that may be due to misallocation. Maybe that may be due to problems with management of multiple locations and divisions. I think I'll stop there. And well, maybe one other thing before I open up for questions, because this I think is a nice example. This paper says, by Haltwanger, Kulik, and Severson says, let's relax what was in my paper with Shea, which was CES plus Cobb-Douglas, or CES plus constant returns to scale, really. They said, let's relax both. They end up estimating roughly constant returns to scale, but they relax the CES, and so they get markup dispersion. So one reaction to this is still misallocation. Just because it's coming from markup dispersion and not some tax wedge, tau, some mysterious wedge, it's still misallocation. But one thing this is really valuable for, I think a paper that I would have discussed too, is Edmund, Medrick, and Zhu asking how costly markups are. Once you endogenize it in a particular way, then think about these gaps in marginal products. There's a high markup firm and the low markup firm. I mentioned the sigma was really important. And one way to think about sigma is if they're really substitutable, then it's going to take a lot of misallocation to pull the relative marginal products of inputs back in line. Whereas if sigma is really low, it's like a lot of diminishing returns. And so the gap, as we reallocate from the low marginal product to high marginal product, the gap closes quickly. So with variable elasticity of substitution, the gap closes more quickly. For a given wedge as you observe, given what looks like dispersion in TFPR, the variable elasticity makes the gap close more quickly. So it turns out the same wedges yield less misallocation in the aggregate. So they were kind of looking at this as CES was a special case. But what I see in this paper, and also the Edward Madrigan and Zhu, is endogenizing market dispersion. And it matters if it's coming from something like variable elasticity of substitution, because not only does it rationalize the markup dispersion, but it says it has particularly smaller aggregate implications, still large, but smaller than you'd get out of just assuming taxes in a CES environment. Okay, I'll stop and open up for questions and general discussion.
Can I ask you a question?
Mm-hmm.
Okay, so this is more of a broad question about the whole literature on misallocation. So I see that there's a big emphasis on understanding aggregate TFP, right? And like my understanding is that aggregate TFP only matters insofar as it contributes to some measure of welfare, like a utility of consumption or something like that, right? And so when I look at some of these frictions, I think that maybe some people are benefiting from this, right? I mean, if you look at financial frictions, and some firms are able to default in contexts where they don't get punished because there's not enough like legal institutions or things like that. So is there a way to kind of try and tease out the effect that these frictions have on, the welfare of agents in a way, right?
Yeah, no papers are coming to mind immediately on that, but I think that's an area to work on, is to say, there's some things that like the government may be favoring some firms versus others, and we might not like, because that might actually increase inequality, like the large firms, wealthy individuals might be politically favored. That doesn't sound like it'll be good on redistribution grounds or efficiency grounds. But there could be other cases like you're illustrating where maybe tolerating inequality actually tolerating misallocation reduces inequality. So I think about like Walmart coming in to Mexico, the gains were, according to David Atkin and collaborators, the gains were for everybody, even though the people whose jobs were wiped out in the informal sector, but the gains were smaller for people in the informal sector who lost their jobs, don't shop as much at Walmart and these other big box retailers. So I think it's really interesting, and that could be like part of the reason these governments are doing that. They're saying, like in India, they're saying this is going to wipe, if I let Walmart in, it's going to wipe out all these small retailers. That doesn't sound good for their welfare. So I completely am sympathetic with, something I started with was the representative agent's welfare. That's missing half the picture, which is what's the distribution of welfare? And is there some interesting trade-off in policy, and some types of policies we might tolerate misallocation because of their distributional implications? We don't want to.
Thanks so much.
May I ask one question here? So in the language of Richards, like he gave last week, so there's this apparent puzzle that is the indirect evidence on the size of misallocation is quite large. But then when this sort of direct evidence comes into play, the effects they find is much smaller. So one thing that they hinted at, and also Banerjee and Duflo hinted at some point, is that maybe these frictions, these distortions interact at some level, and that might actually add up to the large indirect wedges that we find. There's an evidence that you showed today, that Carrick and Vincent, that about this interaction. Do you see any other is there any other literature advancing a lot on this?
I would think the Bento and Restucia and Alp and Peters are along those lines, are saying there's dynamic implications of some of these static distortions. But I feel like there's more room for what you described. Like, it reminds me of Chad Jones's thing about how, if sectors are complementary and some are distorted and others are not, you could get that. It's kind of like the O-ring, Michael Kremer's thing. If you need to produce semiconductors in the Philippines, you need skilled workers, you need reliable roads and electricity. And if any of those are a problem, they're not going to locate a fabrication plant there. So you could improve, 5 of the 10 things you need, and one's still missing, and they might not develop anywhere near as much. So then I'm really interested in that. It's harder to test because of the whole complementarity, but I'm really interested in whether that's played a big role in and like China's growth vis-a-vis India, that China did a lot of things right, and that's why they've really taken off. And India did a bunch of things that were helpful, but haven't done enough to really, like maybe the transportation system really needs reform, or something else that's not that's still holding back development. I think.
Can I ask a question?
Yep.
Sorry, this is going back to really the basic model, but I'm not sure I completely understand why the cost of misallocation is higher when goods are very substitutable. Because if you think, for instance, of two firms and two goods that are pure complements, and because of wedges, a firm produces much less than optimal and the other much more, well, if they're complements, this is going to be really costly. So I'm not sure I understand why misallocation is not costly if goods are not very substitutable.
Yeah, so I'm picturing like, they're already at least Cobb Douglas, they're already like above 1. So they're more than that. And then we're moving them farther above 1. So you're right that the whole story I was talking about complementarity was like, here's different activities that the more they're complementary, the more you move sigma below 1, the more damage done to the other sector of having some cost in one sector. So I was within this class of sigmas greater than 1, and we're making it higher than 1. So I think you're raising some interesting questions about complementarity going the other way. There's also this, maybe you were hinting that a little bit too. If they were perfectly substitutable, you could like substitute around whatever one's distorted, and then there's no distortion. So I think there's some discontinuity at infinite substitutability, but the log normal structure is what I was using and saying it comes out analytically there. But also when I've done it using like Indian data or US data or Chinese data, we just start playing around with the substitutability we assumed, and it's very clear higher that substitutability in the range that we were looking at in the data that we were looking at, the much bigger effects, like with sigma equal 4 than sigma equal 3. But I shouldn't state it as such a categorical thing, either in theory or empirically.
Thanks, that's very useful. Thank you.
Thank you for the question.
Is it possible to also say that one of the possible sources of misallocation is the fact that there are weak institutions in a state, so that you are not relating directly the nature of the institutions to what firms specifically do, but it's just the case that the environment does not allow firms to work optimally. For example, if you have a weak legislative arrangement, for example, is it a way to say that, is it possible to say that that could be a source of misallocation, or it has to be specific to affecting what possibly firms do?
So what did you say? Did you say a weak legislature? Is that what you said, or did you say something else?
Yeah, I'm saying that like weak institutions, for example, could it be a source of misallocation? And I cited as an example, if you have a weak legislative arrangement, like the legislature, for example, is weak, so the legal regimes are not very predictable, something like that.
Yeah, I could see that having big dynamic effects. So, for example, if you're making some investment, like Intel was a non-trivial component of GDP, not necessarily GNP, but GDP in Costa Rica after they located a plant there. I think they were 20% of their exports while they were operating. And a big part of that was probably Costa Rica. You didn't have the cheapest labor. They had some fairly skilled workers, certainly, but was the stability of the promises the government could make. They could say, we're going to keep the tax rate low on you, or here's the export processing zone we've created for you. And the credibility with which they could commit to that was probably pretty important. So I agree with you that there could be lots of misallocation if people are uncertain about the rules changing. Like if there's a lot of investments up front, even like, how much capital do you use in your factory versus how much skilled labor versus, materials? How many things do you do in-house? And that relates to the work that Johannes Bohm and Ezra Oberfield are doing about, the border of what's done within firms versus out firms, and how much do firms specialize. So all of that could easily, you can imagine, feedback. They explicitly talk about how enforcement of legal rights affects how much you do in-house versus have transactions with other firms in that paper. But they're also just documenting really interesting differences in the degree of specialization in India versus say the United States that could very well be a byproduct of the legal system, or you know, how often the tax rates change, or how they're enforced differently.
Thank you.
Pete, I see a couple questions in the Q&A.
Okay.
Stephen Barlow, as companies move up the market chain, as they produce more sophisticated, technically complex, higher value specialist products, is there evidence that this progression correlates to a reduction in misallocation, or is the opposite found?
Yeah, so that makes me think across sectors, which nothing comes to mind right away. But it does make me think of one thing that was kind of surprising, which is when we first wrote the China and India versus the US paper, a common reaction was, look, China and India are in the middle of reforms. So they've changed a bunch of regulations and policies. There's going to be a bunch of reallocation of inputs. It's going to happen so add adjustment costs, and there's going to be a lot of gaps. One thing we found was that inputs just weren't moving around across firms in China and India as much as in the United States. So the idea that, oh, there's a bunch of things jumbling as part of the reform, so there's going to be some misallocation temporarily until things settle down and get reallocated. It just looks like the US looks much more dynamic. Like inputs are flying around firms in the US, so the gaps are smaller, but inputs are flying around. So that doesn't directly address your question, which is like high-tech, more advanced sectors, do they have less misallocation? But at least, you know, the US, if we think about the US having these more advanced sectors disproportionately, in China's like textiles and although increasingly higher tech stuff. It's an interesting question. I think it should be analyzed, investigated, whether there's a pattern like that, like high skilled versus low skilled sectors, or capital intensive or technology intensive by some measure, whether they have more dispersion or less dispersion. That's a good question.
There's one more by Phillips Oluwagbenga Aboluwade. I probably mangled that. I apologize, Phillips. He says, do government intervention programs, it's a big picture question, do government intervention programs affect misallocation? How can they be evaluated?
Well, there's that really nice paper, I know there's a third co-author by Banerjee and DeFlo. I'm trying to remember what year it was published, where it came out. They were evaluating a policy which was like earmarking some loans from state-owned banks to certain mid-sized firms. So it had a random element to it that allowed them to gauge whether there was a high return on average to that policy and whether there was dispersion in the marginal product of capital. And they found really high on average, but tremendous dispersion. So I think, I'm a fan of just using it all the time, using it anytime we can. Any policy where we're like, well, this is a good policy, let's pursue this, just build in some random variation so that we can evaluate whether there's misallocation and whether the policy reduces misallocation. Absolutely. So I guess I view that as more of something that's been done a few times, and there's plenty of room for it to be done more.
Any other questions? There's a question from YouTube. Can you explain the mechanism through which capital or output distortions affects TFP? Well, that's kind of probably too broad of a, that's kind of what much of the lecture was on. I
can try to give the thumbnail intuition though.
Okay, go ahead.
Just like if marginal product is say $10 at one firm and $5 in the other, and you just reallocate unit of capital from the $5 to the $10, you get $5 more of output with the same capital, same total capital in the economy. So if you say output in the economy divided by capital and labor, the denominator hasn't changed, but now output just went up $5. So that's the fundamental intuition by which these gaps in marginal products, if they exist, create the opportunity for increasing TFP by allocating things more effectively. And the bigger these gaps are, the more you're suppressing output relative to your total use of inputs. That's my thumbnail version, Joe.
Okay. All right. Thank you, Pete. Thank you very much. Next week, we will continue. There is a TA session for Leonard Wanchikun's talk on political institutions. That's on Tuesday. And then next week, things are a little bit reversed. We start a new module on agricultural productivity. But David Lagakos will give that lecture on Thursday. And then on Friday, Chris Tonetti will give a lecture on technology diffusion. Thank you again, Pete. Wonderful job. And thank you all the students for showing up. Let's unmic and applaud. You got to unmute your mic or he can't hear. There we go. And we'll thank Mandy Chan again. Okay, take care. Bye-bye.
Thank you.
Thank you.
Thanks, Pete. That was great. Just
Thank you.
fantastic.
Yeah, thanks for all the comments and participation. I think Mandy said I'll get a copy of the questions in the Q&A log.
I think that's right. And then we try to clean it up and post it on the web.
Okay, perfect.
You can monitor how well Kian did.
I was gonna say, yeah, Pete, you can judge whether my answers were appropriate.
probably better than what I could have given. So
it's hard to do under time pressure.
It is. We always talk about whether we should go back and correct all the mistakes that we made answering things quickly. So
yeah.
Anyway,
Noemi, did you have a last question, Noemi, that you were asking in the chat? I saw.
Yeah, but I think I got an answer. My question was, but maybe if someone else has an answer, whether you had nice examples of papers that choose a direct approach that was mentioned, like basically really trying to having a shock that gives wedges and you can really observe those shocks, and then only then doing the welfare loss to misallocation computation.
I have a wonderful example. It's a new paper of mine. So we look directly at interest rate variation using a credit registry.
Okay.
So this isn't exactly cost of capital varying by firms and building it into an aggregate model. I think it's posted on the website if you wanted to take it. It's not an experimental thing, but it's observing direct cost of capital.
Okay, cool. Well, that's exactly what I'm looking for. Thank you. Thanks.
Send me that, Joe. I want to see that.
Oh, okay, great. Take care.
All right. Thanks.
Thanks,
everyone. Thanks a ton, Pete.